Hello, my name is Tim Blewett. I work for Azure as an Azure consultant. And today I'm going to talk to you about Azure Monitor and in particular custom workbooks. Hopefully you can see the screen there in my demo subscription. So I've navigated to Azure Monitor. I can then select Workbooks, and you'll find that by default Microsoft supplies some very useful sample templates for presenting useful information about your Azure environment. We'll pick one, for instance, for virtual machines, perhaps that one there, availability, and just adjust the parameters. And what you find here is that this is a very useful display of availability information, and this is given to you by default. It might be very useful as is, or you might want to tweak it, which we can do by editing. We can edit these parameters here and choose how we select those, and we can also select edit the query that generates these result table. You'll see that this query here is a very similar to like a SQL Server database type language. It's in fact called KQL, Custom Query Language, and in this case is interrogating the log analytics workspace. This is where virtual machines write diagnostic and metric information to. So this is a query that's been written by Microsoft. You can take that and use it and change it as you need. But what we'll do is we'll create one from scratch, and you can see how it's done. So back to Workbooks. And if we create a new workbook, we'll start by adding a query. You'll see that not just log analytics workspaces can be queried for data, but also all of these options here. One particularly useful one is the Azure Resource Graph, and this is the, if you like, the programmatic access to Azure Resource Manager. All of your Azure resources and all their properties and attributes can be interrogated and queried through the Azure Resource Graph. In this case, we'll set to look at all of my subscriptions, and I'll just copy a pre-built query, which we can go through. So if you look here, we're interrogating the resources table, which is a list of all resources. In particular, we're selecting only virtual machines, and we're looking at the power state extended property. We're going to create a new column in the results table called power health, and we're saying that if the machine is in a power state of running, we'll call power health active, otherwise it's inactive. And inactive can mean deallocated, failed, stopped. We only want to know if it's working fully or not. So that's the very raw basic output, a computer, and is it running or not. It's not particularly useful because that information is easily accessible elsewhere, but this is just to demonstrate the concept. If we go to advanced settings, we can perhaps give that a more descriptive name, power health. In fact, while we're there, we can go back to the settings, and the size of the table set of results can be adjusted here. This helps you to conserve the screen real estate. You might not want a huge table if there's only a small number of results to display. Otherwise, you might end up with a lot of blank space. And just for the demo purposes, I'll just restrict the view to the virtual machines in this particular subscription. So there we go. Okay, so that in itself is fairly unexciting, but let's add another query. And if you remember, that queried the Azure resource graph. We also have the log analytics workspace data, and this gives a completely different view of a virtual machine's health, in that it looks at the heartbeat table that we saw earlier in the sample query, and see if that's reporting healthily also. So let me just find a sample query for that. Okay, so I'll just select the workspace that these virtual machines are reporting to. Okay, so they report every minute if they're active, and the agent on the virtual machine is working to the heartbeat table. And this looks at the most recent heartbeat timestamp, and if that particular heartbeat is before 5 minutes ago, 5 minutes, that can be written in hours, days, weeks, months, we'll say that it's deemed inactive if it's not reported a heartbeat in more than 5 minutes, otherwise active. There you'll see that we've got the virtual machine information there. You'll notice that there's an extra virtual machine that doesn't report on there, and that's one that I deleted earlier. So there's still some data in the workspace, but the virtual machine isn't active anymore, even existing anymore. And again, we'll go into advanced settings and just rename the table or the query to something appropriate. So now we've got a couple of queries and tables, if you like, of our results of a slightly different view of a computer's health. It would look slightly better if this was one table with 3 columns. Now, Azure Monitor Workbook querying can't query 2 data sources in the same query, but there is a facility to create a merge type query and merge these 2 tables together. So this is a useful technique, as I'll show you now. So data source of merge, and we'll set the size to be, in this case, very small. And we can add a merge. For those database guys amongst you, then you'll be familiar with these types of merging database tables. In this case, we'll select a full inner join, and this is saying we're only interested in computers that report in both tables. You'll notice that one I highlighted earlier of the virtual machine that was deleted, then we're not interested in that one. Only ones that exist in both tables are of interest for this particular demonstration. And we're going to join the Power Health query that we created first, using the computer name in that one to match against the heartbeat query in this one. Run merge, and we'll see the, if you like, the combined table, the combined output. You'll notice that we have all columns from all tables. We don't particularly need the computer name twice. It has renamed it to a different name, but what we can do is just delete that column and run the merge again. So that gives us a more useful table. If I set the size of this one, just one moment. You can see the reason now of choosing the size of your query appropriately. Otherwise, you end up with a load of blank space. So that's all very a neat summary of the 2 tables above. You'll see here that this virtual machine number 2 is powered on, but it's not reporting a heartbeat. That's because I've stopped the Microsoft monitoring agent for this demo. And you can see why this might be useful just as a rudimentary display of information, in that you might be interested in computers that are powered on but have a problem with the heartbeat. Okay, so this is reasonably useful, but we don't really want to have these 2 tables on here. So what we can do is make those invisible. So they still support the merge query, but we don't particularly want to see them on the displayed workbook. If we edit the query and click Advanced Settings, we can make this conditionally visible. Now we'll create a parameter called show data tables equals show. At this point, the parameter doesn't exist. We can create a parameter, which I'll show you later. But by virtue of it not existing, then it doesn't equal the value of show, and hence it won't be shown. While we're here, I can show you that you can click this option here, and that allows the user to export the result table into Excel, and will allow all columns. We can also add a filter or a search grid above each query for users to search on text. And if you do want to limit the table size, that will, I think, go to a maximum of about 10,000. You can see this is sort of partially grayed out, and once you've stopped editing, I'll show you the resulting workbook. We'll do the same with this one. Again, give the user the option to export results to Excel, and also to search and filter on a text string. Okay, so now we're done editing, and this is our ever more complex table, albeit still not particularly user-friendly. If you recall, we hard-coded the choice of subscription and log analytics workspace within the query itself. And now if you distribute this query to other users, it's likely that they will want to supply their own data sources and have choice of their subscriptions and workspaces. So let's show you how to do that. Back into Edit and edit the query. No, that's not right. Sorry, excuse me. What we need to do first is to add a parameter. Okay, so if we add a parameter called subscriptions, the parameter type here gives you a drop down of different types of parameters. In this case, there's an obvious one called subscription picker. We'll make it a required selection for the user, and we'll allow the user to choose multiple subscriptions. We'll present the list of subscriptions from all of them, and we'll also give the user the option to select all within the drop-down list of options. And in fact, we can make the default selection all subscriptions. Okay, and we'll also do a similar thing for workspaces. In this case, it's going to be a resource picker. What we're after is a list of all the available workspaces that the user can choose. And if you remember back into the Azure resource graph, this is where we would look for and interrogate our Azure environment for Azure resources. Again, multiple selections for the user. It's always good to put an explanation in there and a description of what the parameter is for. And we shall use, one moment. Okay, this will be a query, and it will be, as we saw earlier, from Azure Resource Graph. Now, if you recall when we looked at this earlier, I chose my specific subscription. What we don't want to do is hard code it here, but what we can do is use the parameter that we just defined to supply the list of subscriptions, and this is what the user will input. So they will choose a subscription, and that will then be used as input to run the query to present the list of workspaces. And the query is this one. Again, very straightforward. Interrogate the resources table. We're only interested in workspaces. Give me the ID of all the workspaces within the selection of subscriptions. Again, we'll give the option of choosing all and the default of all. And again, we can optionally select a filter. We shouldn't need to in this case because the query itself should only pick up that, but you can choose to only allow a particular resource type. Okay. So we've got some parameters, and as you'll see, we have our table here, and we can choose a subscription and a workspace, but as you'll notice, it doesn't really have any effect at this point on the results table. What we need to do is to use these parameter options here within the queries that generate the data for this results table. And also, it'd be better if this was placed at the top and above the table. Let's do that. First of all, we can move these, move to the top. Okay, and now we will edit the heartbeat query. So our data source here, previously we'd hard coded this particular workspace, and now we have a parameter that supplies the list of workspaces to interrogate. There we go. Okay, one thing I should have done much earlier is to save the work. Let's do that now, actually. I can choose to store it in a resource group. And I can also store it in an Azure storage account that can be, again, managed through encryption, and that might protect it even more. If a resource group is deleted, for instance, then having it backed up in a storage account might be appropriate. But nonetheless, keep saving regularly. Okay, now it might be that the the user would be interested in those data tables that we saw earlier. In this case, there isn't much else in the tables themselves, but let's just, while we've demonstrated parameters, let me show you another use of the parameter. And we'll define that show data tables parameter that we used earlier that at this point doesn't exist. This will be a drop down of two choices, yes or no. Do you want to show the tables, the supporting data tables, or not? It's not multiple selection, it's yes or no. And in this case, it's a JSON, JavaScript, object notation, language. Don't want to add an option for default items. This is purely yes or no. Okay, and we'll save that. And what you see now is that we have a parameter presented to the user to show data tables with a default of no. But if they select yes, then it does show the supporting data tables. And what we can do is provide more information in those tables that might be more useful. So when a user, for instance, is looking at this neat table here and finds a particular virtual machine of interest, in this case, one that's having a heartbeat trouble, they might then go to the data tables that have more information that can be gleaned from each of these data sources. Now, another thing that you may have noticed was that we hard-coded the definition of what is an inactive heartbeat. We put that to 5 minutes, almost arbitrarily, but that could be anything we want to. And really, we'd like the user to be able to choose what they think is an appropriate heartbeat missing interval. So let's define a parameter for that one as well. Unhealthy criteria. This will be a drop-down list. Required yes, multiple no. Again, this is a JSON query. I'll just readjust the order of the parameters to make it a bit neater and more intuitive. So you'll see here that the options we have from that piece of JSON were these here, fairly user-friendly options of what defines unhealthy in terms of a virtual machine not reporting a heartbeat. But of course, at this point, this parameter is not linked to the query here, and I'll just show you the technique for introducing the parameter to supply the value rather than hard code 5 minutes. It is just the parameter name within the curly braces. Okay, so let me just try something. Yeah, so you can see that if I define the unhealthy criteria as being 2 hours without a heartbeat, I switched this virtual machine agent off within the last 2 hours. So 2 hours ago, it was active and reporting heartbeat. So it just gives the user a bit more flexibility on defining, in this case, what is unhealthy. Okay, let me just check for any other options. Oh, just one thing. Let's go back to the show data tables. You can see there the option we selected to export to Excel gives you the little option there. And again, the search and filter field allows the user to filter the table. So let's just pop that back to 5 minutes. Actually, we haven't done it for this one, so let's do it for that one as well. Edit, advanced. Okay. And just one final thing, I did just talk about providing more information in these tables here, in the supporting tables. So let's just do that. Let's update this particular query. You can see I've still got the power health as before, but just provided all sorts of information, including a resource location and resource group and size and operating system of a virtual machine. If I run that, you'll see that that's all provided there. Now, by default, that has transferred to the merge query. So we might just want to edit the merge query and just pick off a selection of those that we can always refer to the full table for details if we like. So here we are. We might not want, let's just take a couple out, for instance. Okay, so that just supplies, if you like, a neat table that the user can interrogate, and if they would like to find a particular virtual machine of interest, then they can look at the supporting tables where you can provide any of the attributes that were there in this case, the resource graph query. There was one further thing that I perhaps would like just to show you. So let's edit this and edit the merge query. I'm going to add a new item into the columns of of the merge query, and it's based on, if you like, the combination of the power health and the heartbeat health. But we're really interested in this, if you like, a bit of a spurious scenario is virtual machines that are active but are missing a heartbeat. So if we add a new item, it's a bit clunky, this editing, but if I show you it, it might be helpful to you. So the first line here is the default condition, and what we want to do is to say if we'll describe this type of virtual machine that's active but without a heartbeat as unhealthy, and anything else is healthy. If the virtual machine is switched off, that's okay. If it's switched on and reporting a heartbeat, that's okay also. So if we first, the default condition we're going to say is just a static value of healthy. We'll add a second condition to say that if the power health equals static value of inactive, that's also healthy. And then a third condition to say if power health is not equal to heartbeat health, we're going to define that as unhealthy. Okay, so there's our added column. We'll call that overall health. And we'll also move it up. There. Let's try a run merge. Okay. Let's remove those tables at the moment. So what we have now, we've used those that merging and conditional columns to form another column based on the output and values of each of these columns that we've generated earlier. So in this case, we have healthy virtual machines defined by being active and issuing a heartbeat, or by being switched off. That doesn't mean to say that it isn't a problem, but in this particular demonstration, we're just looking at this combination of power active, heartbeat inactive, and describing that as unhealthy. We can sort on, if they had 1,000 virtual machines and we're looking for that type, then we can sort on that, for instance. Okay, and that's it really. That's hopefully shown you quite a few different techniques of creating your own custom workbook. I say that particular case might not be very useful, but hopefully the techniques can be used to help you in future. Okay, thank you very much.